Hello, today we'll discuss the Kirchhoff's second law. In previous lecture, we have discussed the Kirchhoff's current law. So in Kirchhoff's second law, which is also called as the voltage law, it states that and at any instant in a closed loop, the algebraic sum of the EMF acting around the loop is equal to the algebraic sum of the potential difference around the loop. So let us consider this circuit. There are three resistances are there, and the voltage drop across this resistance is V1, across this V2, across this is V3, and total supply voltage is V to this circuit. So as per the Kirchhoff's voltage law, this is one loop. So applied voltage is equal to the sum of the potential difference in the circuit. So the potential differences are V1, V2, V3. So V is equal to V1 plus V2 plus V3. Now let us consider one example. Here in this example, total voltage is given of the circuit is 12 volt, and these are the potential differences across this resistance R1. It is V1, V2, V3, V4, and V4 is given, then V2 is given, and total voltage is given. We are required to find this V1 and V3. So first we will apply the Kirchhoff's voltage law to this loop and Kirchhoff's voltage law to this loop. And one more loop we can also consider, this is a external loop. We can also apply the Kirchhoff's voltage law to the external loop. So we have to find V1 and V3. So we have to apply here Kirchhoff's voltage law to this loop A. Total voltage is equal to V1 plus V2. Around this loop, this voltage is equal to this voltage plus this voltage. Okay. So as the direction of the current is opposite to this, so we can consider this is there is actually the fall in potential in going in the direction of the current. Okay. So therefore V1 minus V1 minus V2. So V1 is equal to V1 plus V2. So in this way, so it is V is given here. V is at 12 volt, and V1 we have to calculate. V2 is also again given, it is a 8 volt, and we can now find V1. V1 is equal to 12 minus 8, therefore it is a 4 volt. Okay. Now we have to find V3. V3, for that we have to also apply Kirchhoff's voltage law to the loop B. So if there is any EMF sources in this second voltage, no, there is no voltage EMF voltage sources. So it is a 0, and we are going opposite to this. This is V3. We are going opposite to this V4. It is V4, and we are going in the same direction as far as the voltage drop across the V2 is given. So it is minus V2. So V3 we have to calculate, and V4 it is given. V4 it is a 2 volt. It is a 2 volt, and V2 is given, and V2 is 8 volt. 8 volt it is given. So now V3 is equal to 8 minus 2, it is equal to 6 volt. So in this way we can find the voltage V1 and V3 by applying the Kirchhoff's voltage law. Let us consider one example now. This voltage source is there, this resistance is there, this one more resistance is there. This voltage is given 5 volt, and this is I1, this is R1 is 30 ohm, R2 is 60 ohm, and this R3 it is given 30 ohm, and this is a I3 it is given, it is a 1 ampere, and we have to calculate I2. So determine I1 and I2. So see, we have to consider all the concept what we have seen as per the series and parallel circuit is concerned. So here this is the total voltage source, and the current is coming here, and the current is actually divided into this. So we have to find this. How we can calculate this I3? Just by the current division method. This I3 can be found if you know the total current flowing through this circuit. So total current is suppose here I1, okay, into we have to find this current flowing through this I3. So we have to take the resistance of opposite branch. This is R2 divided by the addition of both the resistance R2 plus R3. Okay, but here we have to find I1. Okay, so we have to solve this equation for I1. I1 is equal to R2 plus R3 by R2 into I3. I3 is given, R2 it is given 60, R3 is given it is a 60, R2 is again it is a 60, and I3 is again here 1 ampere. So it is a 90 by 60, it is 9 by 6, and this is coming 1.5 ampere. So this is a I1 we have got 1.5 ampere. So prima facie we can say that if this current is 1.5 ampere, 1.5 ampere now we have got, and if the 1 ampere current is going in this branch, so remaining 0.5 may go in this branch. So we have to apply again KCL at this junction. This is junction. So apply KCL at this junction. The coming current is I1, and this is I2 and I3. This is the going current. Here it is I1 is 1.5 ampere. We have to calculate I2. I3 is given, it is 1 ampere. So I2 is equal to around. Next example is This voltage is given 20 volt. This is 25 ohm, 40 ohm, 15 ohm, 10 ohm, and this is actually the C. So I have to calculate VAB. We have to calculate VAB. So VAC is equal to, what is the voltage across this AC is equal to total voltage, that is a 20 into the, this is the, this is R1, R2, R3, and this is R4. We have to find the voltage across this AC. It is a total voltage 20 into, as we have to find the voltage across this resistance. Therefore, R3 is 15 divided by 15 plus 25. If you solve this, we'll get this 7.5 volt. Again, we have to find VBC. VBC is the voltage across this point, and we should have know the total voltage of the circuit V, as we have to find this. So this is a 10 divided by this 10 plus 40. So it is a 4 volt. Okay. So now we have got here VSC is equal to 7.5 volt and VBC is equal to 4 volt. Now we have to apply the Kirchhoff's second law, that is Kirchhoff's voltage law, to this loop. We have to apply the Kirchhoff's voltage law to this loop. So what is it? Is a VAB, VBC plus VC is equal to 0. To know this ABC, ABC plus VCA is equal to 0. And we have with us VAB. We have to find VAB is equal to VBC, it is a 4 volt, and VCA it is given, VCA is there, but we have VAC. So we have to take, we have to write here minus sign, minus VAC, because we have the VAC voltage. So, but as per the Kirchhoff's voltage law, it should be VCA. Therefore, we can write like this. And therefore, VAC is, we have got how much is the voltage? VAC is 7.5 volt. VAB is equal to 7.5 volt. 7.5 into 10 to the power 6. 6 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 into 10 4 minus 7.5 volt. VAB is equal to 7.5 minus 4, and it is equal to 3.5 volt. So VAB is equal to 3.5 volt. So in this way we can find the current and current flowing to any branch and voltage across the any branch. In this way, this is the voltage. Thank you very much for watching the video.